During the last session, what we have considered is the line parallel to one of the planes and perpendicular to the other, or line parallel to both the planes. Those two conditions we have seen. Now, a bit more complicated. That is, the line is parallel to one of the plane and inclined to the other. That is the next condition. Next condition is the line is not parallel to. The line is parallel to one of the planes and it is inclined, not perpendicular to the other plane. It is inclined to the other plane. That is the next condition. And by the way, when the line is parallel to both HP and VP, that condition is can be considered as a condition in which the line is perpendicular to the profile plane. Actually, when the line is parallel to both HP and VP, the line is perpendicular to our profile plane. So the same condition is applicable if we consider the profile plane also. When the line is perpendicular to VP, then in that condition, the line is parallel to HP as well as parallel to profile plane. When the line is perpendicular to perpendicular to HP, so in that condition, the line is parallel to VP as well as parallel to profile plane. So when the line is perpendicular to one of the planes, it is parallel to both the other planes. Now, the next condition is the line is parallel to one of the planes and inclined to the other. So let's see how it comes. In this case, what we describe is a line which is inclined to HP and parallel to VP. That is the condition. So that is the pictorial representation will be something like this. That is, here it is shown that the VP as well as HP is given. Now this is the line. This line is assumed to be parallel to VP and inclined to HP. So this is the line AB, and it makes an angle of theta with HP. The angle, the line makes an angle of theta degree with the HP. And when the observer looks from the front, in order to get the front view, the points are projected like this, projected to the vertical plane, and here we obtain the front view by joining the endpoints of this, the endpoints in the projection, that is A dash as well as B dash, we can get the front view. So this is A dash B dash, that is the front view. And now the angle of the front view, that is the line A dash B dash, the angle of the line A dash B dash with the XY line will be same as theta. How it comes, so we can see in a trio. That particular angle will be same as theta. That is, when the line is parallel to VP, the front view is showing an angle which is equal to the inclination of the line with respect to HP, when that line is parallel to VP, that condition. So now in order to get the top view, we look from the top, and the endpoints A and B are projected to the HP, and here we obtain the top view. So this top view will be a line which is parallel to XY. Since the line is parallel to VP, the top view should be parallel to the XY line. That condition we have already seen. When the line was parallel to HP, the front view was parallel to XY line. When the line was parallel to VP, the top view was parallel to XY line. So in this case, the line is parallel to VP and inclined at an angle to HP. So the front view is inclined at an angle to XY line, and the top view is parallel to the XY line. So this is the line AB. Now, as usual, we join A dash with the XY line using a perpendicular line to XY, and likewise the front view also. Now, if we extend the line, in such a way that it intersects with the HP, we extend the line is currently not intersecting with HP. So suppose we extend the line in such a way that it intersects with the HP. Since the line is inclined at an angle to HP, it will intersect. If we extend, it will intersect with HP. But if we, since it is parallel to VP, even if we extend in any of the directions, it won't intersect with the VP. So since the line is inclined at an angle to HP, if we extend it to one of the sides, It can be either towards the left or towards the right. In this case, it is towards the left. If we extend the line towards the left, then it will intersect with this HP. And this particular point is known as the trace. And the trace will be in a line which, if we extend the top view, also, then the trace of the line, that is the point of intersection of the line with the reference plane, that is known as the trace. When it is intersecting with HP, it is known as the horizontal trace. When the line is intersecting with VP, it is known as the vertical trace. In this case, we have only horizontal trace, and the horizontal trace, and this particular point will be lying in the extension of the point of the top view of the line. So, and in that same case, we can extend the front view also in order to meet the XY line. So that is this part, this extension, when we project this extension to the front view, it will be like this. If we extend this projection, or if we project this extension, project this extension of this original line into the front view, then it will look like this. It will be similar to like this. And so that is, it is actually an extension of the line A dash B dash itself. So if we increase the length of A dash B dash towards the left, then it will be like this. Then at this point where this line, the actual line AB intersects with the HP, the same point can be obtained. The projection of that same point can be obtained by extending the front view towards the XY line, and the point of intersection of this line with XY line, that is this point. This point is the point of intersection of the extension of A dash B dash, that is the front view, with the XY line. And that particular point we can be marked as H dash. Since it is the front view of HT, it is the front view of the horizontal trace. Horizontal trace, we commonly denote it with HT. So it is the front view of the horizontal trace, and we commonly mark it as H dash, and the actual point as HT. So now, if we convert it into two-dimensional drawing, that is orthographic projections, we don't have to draw this three-dimensional representation. What we have to draw is, we have to draw only this two-dimensional representation, or two-dimensional orthographic projection only. So it will be like this. See, here is the XY line, and here it is the front view, A dash B dash, and the front view is making an angle of theta degree with the XY line, and AB, the line AB, that is the top view, is parallel to the XY line, and we extend this A dash B dash to XY line so that we obtain the H dash, and from H dash we drop a projector so that it intersects with the extension through the top view. So this point is HT. This point is marked as HT. That particular point is an important point. HT is an important point since it is the point of intersection of the line with our horizontal plane. HT is the horizontal trace. Trace is the point of intersection of a line with the reference plane. Horizontal trace is when the line is intersecting with the horizontal plane, it is horizontal trace. When the line is intersecting with the vertical plane, it is known as the vertical trace. And point of intersection of line with the profile plane is not, we are not considering it. So obviously there is a profile trace, but we are not using it. We doesn't have to use it in any of our drawings. But horizontal trace as well as vertical trace is of importance. And how to obtain it? To obtain the horizontal trace, what we have to do is, we have to extend the front view in such a way that it intersects with the XY line at a point H dash. Then that particular point is projected to the top view or extension of the top view. In some cases, we don't have to extend the top view, and you even doesn't have to draw the H dash also, because this line will be intersecting, that line A dash B dash will be intersecting with the XY line in some cases. So in that case, the point of intersection of XY with the A dash B dash will be the H dash. So in that case, in that particular case, the HT will be lying in the top view itself. In all the other cases, we have to extend the front view as well as the top view in order to mark the H dash as well as the horizontal trace HT. Now let us see this particular thing in our Creo. So in Creo, this is the situation. See this line, this yellow line. This yellow part, it represents the line, straight line. So that particular straight line is now parallel to VP. In order to prove that it is parallel to VP, let us see if, the front view, I mean left side view. See, in the left side view, this is parallel to VP. This line is represents VP, and this is our actual line. So this line is now parallel to VP. So that is the condition. Now, if we look from the front, see the front view is inclined at an angle. The front view is inclined at an angle, and this the view of the front view, the inclination of the front view, it is equal to 30 degree. The inclination of the front view with the XY line is 30 degree, and this line is made at an angle of 30 degree with the HP. So in the front view, we get an angle which is equal to 30 degree with the XY line. This line, the bottommost line represents the HP, and this is our actual line. And this actual line, the front, this is the front view of the actual line. The front view represents, the front view is inclined at an angle of 30 degree with the XY line in this case. Now, if we move on to the top view, if I move on to the top view, see the top view is parallel to XY line. So here is the XY line, this orange line, that is the XY line. It represents the XY line in actual top view. So then this is the top view of the object. Now let's see what is the length of this top view. See, the length of the top view is only 8.66. So the actual length, the true length of the drawing is 10 units. I created it as 10 units. That is, say it is 10 centimeter. If it is 10 centimeter, the top view is having only a length of 8.66. That is, the top view, the length of the top view is reduced. Why it is reduced? That you know why it is reduced. But in front view, how it is coming up? Let's see. What is the length in the front view? See, in the front view, it is 10 itself, because in the front view, since it is parallel to VP, when the line is parallel to VP, when we are projecting these endpoints, the projections lines or the projectors as well as the actual object and the front view, it creates a rectangle itself. It creates a rectangle in which the opposite sides are always equal. The opposite sides are equal. So since the opposite sides are equal, when the length of the actual object is 10 centimeter, the front view will also have 10 centimeter length. So that is the condition. But in the case of top view, when we drop the top view, so let's see it in two-dimensional condition. See. See, this is the condition. So in this case, here is the condition. So this is the rectangle that I was saying about. This line, this line, this line, as well as this line. This forms a rectangle. So in this case, this distance is equal to this distance, since VP is parallel to this line. So since this is a rectangle, this angle is 90 degree as well as this angle is 90 degree. So these two angles are 90 degree. Obviously, this also has to be 90 degree. So this is the condition. So then this line is equal to the length of this line. This capital AB should be equal to the length of A dash B dash. So that is the front view. That is the case of the front view. But when we consider the top view, see the top views. Top view, this is the rectangle that is not a rectangle actually. It is a quadrilateral or a trapezium. In that case, it is a trapezium, in which case this side is parallel to this side is parallel to this side. These two sides are parallel, and this side is not equal to or not parallel to this line. So that is the difference. So in this case, the top view, the length of the top view is somewhat different, somewhat lesser value. So if this angle is theta, that we already know. So you can find out the length of this value, the length of this distance. That is equal to this distance, capital AB sin theta. That I think you know. Sorry, cos theta, adjacent side is, it is cos theta. So AB cos theta. So that is this distance. So this distance is equal to, that is the length of the top view can be found out. The length of the top view can be easily found out even without drawing it. We can found out it is equal to AB cos theta, where theta is the inclination with the HP. So that is the condition. So as we said, the top view, the length of the top view is a reduced length, and that particular length can be calculated. If you want to calculate it, you can calculate it using the actual length of the line as well as its inclination with the HP. Its inclination with the HP. And now the condition is, since the line is parallel to VP, the top view should be parallel to the XY line. The top view should be parallel to the XY line. So this is the first condition. That is, the line is parallel to VP and inclined at an angle to HP. When the line is inclined at an angle to HP, the front view will give you the inclination. And this inclination, we call it as the true inclination. That is the actual inclination of the object, or the actual inclination of the line with the HP or with the VP is known as the true inclination. So here it is true inclination with the HP. So in this case, true inclination with the HP, and a true inclination with HP is always denoted by theta. The true inclination with the HP is always denoted with the theta. So in order to remember it, this is the symbol. So theta is, this is the symbol. We draw a circle and draw a horizontal line. This horizontal line represents the HP. So the true inclination with the HP is theta. Then if there is a true inclination, obviously there should be an apparent inclination also. We will come to it. What is an apparent inclination or a relative inclination? What is it? That we will come to know. And true inclination with HP is always denoted with theta. And when the line is parallel to VP in the front view, we will get the true inclination with the HP. So that is the initial condition. Now the front view is inclined to XY line, and top view is parallel to XY line. So now the next condition, let's see the next condition. That is a line which is inclined to VP and parallel to HP. The second condition is the line is, or the next condition. The next condition is a line which is inclined to VP and parallel to HP. So here is VP, here is HP, and here this line AB is now inclined to VP and parallel to HP. So this makes an angle of phi with the VP. This is the true inclination. That is, true inclination with the VP is always denoted by phi, and when we write phi, it is like this. We commonly write phi like this. So this means in theta, this is HP, in true inclination with HP, and this is true inclination with the VP. In true inclination with the VP, there is a vertical line. So in order to remember it, in both the cases, in theta as well as phi, there is circles, and in HP it is the horizontal line theta, and in VP it is phi. So true inclination with the VP is always denoted by phi. And in order to get the top view, we look from the top and we project the points A and B to the HP. So we will obtain small letter A and small letter B there, and we join it to get the top view. So this is the top view. Now this top view is again inclined at an angle phi with respect to VP, I mean with respect to XY line. So that is, when the line is making an angle of phi with the VP, and it is parallel to HP, the top view will be making an angle of phi with the XY line. So that is the condition. So now in order to get the front view, we look from here and we obtain the front view on the VP, and this is the points A dash and B dash, and this is the front view. Now, if we extend the line, then obviously the line will intersect with the VP. If we extend the line, then the line will be intersecting with the VP. And in this case, instead of the front view intersecting with the XY line, it will be the top view that will be intersecting with the XY line. See here, even if we extend the front view to any length, it won't intersect with the XY line, since the XY line is parallel to the front view. So it won't intersect with XY line. But if we extend the line AB, to the left side, towards the left side, then in that case, the top view will intersect with the XY line. So that point, the point of intersection of that particular point, the point of intersection of the extension of the top view is projected to the XY line in order to, the point of intersection of the XY line and the top view, and that particular point is projected to the front view in order to get the vertical rays. This is the case of vertical rays. Since the line is intersecting with the vertical plane, we obtain the vertical rays. And in order to get the vertical rays, what we do is we first obtain this point, small letter V. This point is obtained by extending the top view in such a way that it intersects with our XY line, and that particular point is known as the small letter V, and then this V is projected to the front view A dash B dash in order to get the vertical rays. So this is the vertical rays. So if we convert it into two-dimensional drawing, it will look like this. See, this is the top view, and the top view is extended to get the vertical rays. Sorry, the top view of the vertical rays. This V represents the top view of the vertical rays. So then that V is projected to the extension of front view A dash B dash in order to get the vertical rays. So this point is the vertical rays. So the vertical rays falls on the extension of the front view, and the horizontal rays falls on the extension of the top view. So that you have to remember. So these two conditions, consider these two conditions, these two figures. So H dash, A dash and B dash both lie in the same straight line. It is an inclined line, and this particular line makes an angle of theta with the XY line in this particular condition. This particular condition is when the line is parallel to VP. So, but in all the cases, H dash, A dash and B dash will be lying in the same line, and HT, A and B, top view of A and B as well as HT will be lying in the same line. And in this case, it is a horizontal line. Here also, if you see, V, A and B are in the same line. V, A and B are in the same line, and VT, A dash, B dash are on the same line. So this you have to remember. That is, always the vertical rays A dash and B dash will be in the same line. Likewise, O dash, always HT, A and B will be in the same straight line. So let's see this condition, that is the condition of a line inclined to VP and parallel to HP in Rio. So this is a line which is inclined to VP. So I hope you can identify it. It is a line which is inclined to VP and parallel to HP. A line inclined to VP and parallel to HP. If we go to the front view, See, the front view is parallel to the XY line. The front view is parallel to the XY line. And the length of this front view will be a reduced length with a factor of cos of phi. So this length can be found out by the true length multiplied by cos phi, where phi is the inclination of the line with respect to the VP. So that we can find out. Theoretically, if you want to find it pictorially, you have to draw the front view. So in this front view, you get the length, a reduced length. And if I go to the top view is inclined at an angle with the XY line. Here is the XY line and here is the actual line. So the top view is making an angle of some phi with the XY line. See, in this case, I have created this with an angle of 45 degree with the VP, and let's see whether it is the same. See, the top view is making an angle of 45 degree with the XY line, but in the front view and in the top view, the length is 10 millimeter. I mean 10 centimeter. It is the actual length of this line, that is 10 centimeter is the actual length of the line. So in the top view we are getting the true length as well as true inclination when the line is parallel to HP. So this condition you have to keep in mind, that is when the line is parallel to HP, in top view you will be getting the true length as well as true inclination with respect to VP you will get, that is phi, the angle phi you will get. And if I go to the front view, see the line is parallel to XY line, so we cannot measure the line angle, so it is 0 degree, and the length of the line is reduced, that is 7.07. Since it is 45 degree, 10 multiplied by cos 45. That will give you 7.07 approximately. There will be some more digits will be there, but we are omitting that. We are restricted to only 2 decimal points. So it will be giving you 7.07 as its length. So it is a reduced length. So these conditions that you have to keep in mind. That is when the line is parallel to HP, the top view will be giving you the true length and the true inclination, and the front view will be of reduced length and parallel to the XY line. And the next is when the line is parallel to VP, the top view will be parallel to the XY line, and the front view will give you the true length as well as true inclination with the HP. So these 4 conditions, actually 2 conditions, and from these 2 conditions, the 4 statements that you have to, 4 facts that you have to keep in mind. It is when the line is parallel to HP, what is the condition of the front view as well as top view? When the line is parallel to VP, what is the condition of the front view as well as the top view? That conditions that you have to keep in mind. And actually we have to go to the next condition. Before that we will do 2 problems related to this one, 2 exercises related to this one. And you might be remembering how to find out the H dash as well as HT, and how to find out the V, the point V as well as VT. Now, coming to the traces of line, we have already seen how to do that or find out the traces of the line. So actually the traces of the lines are the points of intersection of a line with respect to the reference planes. In some cases the line itself intersects with the reference plane. In that case we don't have to extend it, otherwise you have to extend it. So a line itself or its extension, wherever touches HP, that point is called horizontal trace. Similarly, if a line itself or its extension, whichever is touching the VP, that particular point is called the vertical trace. So VT is a point on the VP. The vertical trace is a point on the VP, and hence it is called the front view of a point in VP. The VT is a front view actually. VT is a front view of a point. Since it is a point on VT, the top view will be on the XY line. And the HT, it is a point on HP. Hence, its front view will be on the XY line, and its top view is called the HT. In projections, actually, the actual point is not represented, only the projections are represented. So, the front view of VT is denoted as VT itself, and the top view of it is represented as small letter v. And the top view of VT always comes in the XY line. And the top view of HT, the top view of HT is marked as HT, and the front view of HT, since HT is in the horizontal plane, the front view of HT is always marked as H dash. So whenever H dash comes, it is the front view of HT, and whenever small v comes, it is the top view of VT. So now, how to locate HT? HT as well as VT, how we will locate it? When the projections are, we have the projections, then how to draw it? That is the condition. First, what we have to do is, when we have to locate the HT, we begin with the front view. As I have already showed you, that is, we begin with the front view and extend the front view up to the XY line. And this point is named as H dash. We extend the front view to XY line, and this particular point is named as H dash. And then we draw a projector from H dash, and the top view is extended to meet this particular projector. So there are 4 different steps. The first is we extend the front view, and the point of intersection of this extension with XY is marked as H dash. So this is the second step. And then the third step is we draw a projector from H dash, and in the fourth step we extend the top view to meet this projector. And finally, the point of intersection of this projector with the extension of this top view is marked as HT. And now the steps to locate VT. The similar 4 steps are there. In this case, we begin with the VT, and we extend the top view to XY line. So we begin with the top view, and we extend the top view to meet with the XY line. And then we name this particular point, the point of intersection of XY line and the extended line. This point is marked as small letter v. So then we drop one projector from V, and we extend the front view to meet this projector. And this point of intersection of this projector with the extension of the front view is known as VT. So if we have the projections like this, see, here it is A dash, here is B dash. Actually, B dash is not fully visible, sorry. So A dash is here, and as well as B dash is here, and A is here, and B is here. So the complete projection of a line is given. This is the condition when both the line is in. This is the condition when both the line is inclined to both the planes. So this particular projection, that is the condition when the line is inclined to both the projection, both the planes. So that we will come to later. So in this case, in order to get the HT, what we do is we have to extend the line front view, extend the front view so that it intersects with the XY line. Then that particular point is marked as H dash. Then we drop a projector. Then we extend the top view. So the top view is extended towards the XY line so that it intersects with the XY line. So in order to find out the VT, we need V. So now this point of intersection of this line, the projector line with the extension line, is known as the HT. So this point is marked as HT. Now the point of intersection of this extension line of the top view with the XY, that is this point is marked as V. And now we have to drop a projector from V and extend the front view. The front view is already extended up to XY line, then we have to extend it further in order to intersect with the projector through V. So we extend it so that it intersects with the projector through V, and this particular point is known as the VT dash or VT. Since it is a front view, we can use dash along with it, but normally we doesn't use the dash along with it, we use only VT. So now from this one, from this figure actually you have to keep in mind, because it is a figure which is of very importance to us, very importance in the sense to solve many of the problems we can use this particular figure. How it can be used, that we will come to later. So this is a figure which is of importance. Then from this one we can get some points to remember. That is, the points H dash and V are always on the XY line. So see, V as well as H dash, both are always on the XY line. That you get the point. So then VT dash and V are always on one projector. Since we know that V and VT dash are projections of the same point, that is the top view and front view of the same point, V and VT. Both are the projections of a same point, so it should be on the same projector. V and VT are on the same projector. Likewise, H dash and HT are on the same projector. It is being the same, the projections of the same point. So H dash as well as HT, both are on the same projector. Now the front view, H dash and VT dash always collinear. So see, this is the front view. This is the front view, H dash and VT. These are always collinear, that is in the same line. All these three things, that is the front view, the H dash as well as VT dash or VT. These three things are always in the same straight line, or it is always collinear. So this also you may have to remember. And then the next condition, that is the top view. This is the top view, HT and V, all these points or all these things are on the same straight line. So these 5 points that you have to remember, that is the points H dash as well as V are always on the XY line, VT and V is always on one projector, HT and H always on one projector, FV, that is front view, H dash and VT always collinear, top view V and HT always collinear. So these 5, if you know or if you understand these 5 concepts, it will be easier for you to solve the problems in which the line is inclined to both XY as well as, both HP as well as VP. So this is as I said, this is a figure of importance. So let's see it when we draw the projections of lines inclined to both HP as well as VP.